Okay, today we have indeterminate form. Okay, put your phone away. I don't care if it's your mom or your grandma. I really don't care. But okay, indeterminate form. So, Mr. Ricky, if you stick a -3 into the numerator, what do you get? That's the top, yeah. Uh-huh. Zero. If you, Mr. Collins, if you stick a -3 in the denominator, what do you get? Zero. So indeterminate form is when you get 0 over 0. Okay? Problem's name. -3 squared is 9. 3 times -3 is -9. 9 plus -9 is 0.
Oh, I was looking at the wrong one.
We're right here. All right. So, when you get 0 over 0, it's indeterminate form. If you get like 5 over 0, it does not exist. Okay? That's easy. Okay? If you get 0 over 7, it's 0. Okay? But when you get 0 over 0, it's indeterminate form. So then you got to start searching for the limit. So, for this first one, it's pretty easy. Okay? We're going to factor. Okay? So how do we factor the top? Take out an x and you get x squared plus x minus 6. How do you factor the bottom? Take out an x and you get x plus 3. Hey, I think the top factors some more. How does the top factor? X plus 3, x minus 2. Generally, you want things to cancel. So if you see something on the bottom, top probably going to have something cancel too. All of a sudden, we get x minus 2. And we have the limit as x approaches -3. If we stick the -3 in there, we get -3 minus 2. The limit is -5. The limit exists. The limit exists. It's -5.
Oh my gosh. Wild. My mind has been blown.
Okay. So, because it's annoying. Okay. So, Liv. Okay. I'm guessing this is 0 over 0. So since you were playing video games there, let's see if you know what to do now. Take out an x squared on top, and you get x squared plus 3x plus 10 on the bottom. There's a lot of dissing going on here. Of course, I started it, but yeah. So take out an x and you get x minus 2. Okay. So x minus 2. So what do you think one of the other, we keep factoring the top, what do you think one of the factors is going to be? X minus 2. Amazing. And then it's going to be x plus 5. So this cancels with this. One of these cancels with one of these. So I get x times x minus x plus 5. Okay. If we stick in a 2, we get 2 times 2 plus 5, which is 2 times 7, which is 14. We good there? So we don't have to do that one, right? No. Okay. Let's look at this one. Ooh, square roots. Ooh. All right, so if we stick a 4 in there, we get a 0 on the top. If we stick a 4 in here, we get 4 plus 5, which is 9. The square root of 9 is 3. 3 minus 3 is 0. Indeterminate form. So, to solve it if it has square roots involved, we multiply by the conjugate of either the numerator or denominator, depends where the square root appears. Okay? So we have x minus 4, and we have 3 minus the square root of x plus 5. So we're going to multiply both the top and bottom by 3 plus the square root of x plus 5. So in the numerator, you're just going to leave it the way it is. X minus 4. We're not going to try to FOIL that. Do not try to FOIL that, because you'll see why we don't even need to bother to try to FOIL that. Denominator FOIL. 3 times 3 is 9. Outers and inners in conjugates always cancel. What's the square root of x plus 5 times square root of x plus 5? X plus 5. So it's going to be minus the quantity x plus 5. Well, if we do the math, we have an x minus 4 on the top, a 3 times plus the square root of x plus 5 on the top. What's 9 minus 5? 4. And we, Mr. Bierschbach, you made a mistake somewhere. Where did you go wrong? X plus 5, 3 times. Oh, there it is. I see it. Okay. So I get 4 minus x in the denominator. Hey, that looks a lot like x minus 4, doesn't it? Yeah. Okay. So in my numerator, I have x minus 4 times 3 plus the square root of x plus 5. My denominator, if I take out a negative 1, I get x minus 4. Oh, wow, I can cancel. And now if I cancel, now I can finally stick my 4 into this. So it's 3 plus the square root of 4 plus 5. What's the square root of 9? 3. 3 plus 3 is 6. Divided by negative 1 is negative 6. Negative 6 is the limit. What if the square root appears in the numerator, Elijah? Then you just leave it there. Not the answer I was looking for. So when you're playing around with your computer while I'm teaching, that's not the best thing, because then I call you out because, All right, I am really ruthless today. Okay, so what do you think I multiply by, Trey Smith? No. No. If you were listening closely, I multiply by the conjugate of whatever is involved in the square root. I said that last time, a little earlier today. The square root of 5x plus 4 plus 3. Mr. Collins, we're not worried about pleasing the math gods. We're worried about finding the limit. So we can have a square root in the denominator right now. Okay? So when you're working with finding a limit and you're in indeterminate form, wherever the square root is involved, you multiply by the conjugate of the square root to get rid of the square root. All right, so if we do this, we FOIL the numerator. What's the numerator going to become? Oh, who haven't I picked on? Oh, I haven't picked on Makira forever. What's the numerator become, Makira?
The quantity of 5x plus 4 minus 9.
All right. My denominator I'm going to leave as x minus 1 times the quantity of the square root of 5x plus 4 plus 3 and the quantity. So 5x plus 4 minus 9 is really 5x minus 5. I don't know where you got the x minus 1 from. You're just trying to skip a step, Mr. Collins. No skipping steps in calculus. Now, what Mr. Collins was going for is, what do we have to do in the numerator? Factor out a 5. What's undefined? So if we cancel out my x minus 1s, I get 5 over the square root of 5x plus 4. And that's a plus 3. Now if we stick in the 1, 5 times 1 is 5 plus 4 is 9. Square root of 9 is 3. We get 5, 6. Okay? So, Mr. Ricky, since you're so smart and saying things first, what's that one? You get 0 over 0, so it's indeterminate form. But now, we need to think back to trigonometry. All right, get out your notebooks. Notebooks. We got to take some notes.
I've been sold a false bill of goods. We haven't learned anything. We haven't went over anything yet.
Hey, I found my trig notes. Yep.
Trig identities.
Oh, you gotta be kidding me.
You thought you'd never use these again. Oh, chapter 3.
I had the note card in my
Wait, I have it.
Trig identities. Remember
Why do you hate us, Beardbot?
that the sine squared of theta plus the cosine squared of theta equals, look at that. We got some smart people in here. Sine squared of theta plus cosine squared of theta equals 1. Know that one. Okay? Know that the tangent squared of theta plus 1 equals the secant squared of theta. Very good. And the cotangent squared of theta plus 1 equals the cosecant squared of theta. Those are called the Pythagorean identities. You need to know those.
It's terrible. It just burned my forehead right now.
I know that like long packet.
Yeah, and I remember.
No one knew how to do it.
I remember.
No one knew how to do it. Everybody knew how to do that.
Difficult.
It was difficult.
Long to do. Me and Ethan
You're sitting on the desk with us.
All right. Now, double angle formulas. The sine of 2 theta equals 2 sine of theta cosine of theta. Yes, that's an equal sign. Sine of 2 theta equals 2 sine of theta cosine of theta. The cosine of 2 theta has 3 of them, remember them? One's cosine squared of theta minus sine squared of theta. No, Matthew, none of them have tangent in it.
How? I'm just gonna start guessing them.
This was a little while ago.
It's like 6 months ago.
Another one, let me think if I can remember it. I think it's 2 cosine squared of theta minus 1. And the other one is 1 minus 2 sine squared of theta. I'm pretty sure it is. Because sine squared of theta is equal to 1 minus cosine squared of theta. So minus a negative is plus positive. Yep, that's right. And then cosine squared of theta is equal to 1 minus sine squared of theta. So 1 minus 2. Yep, that's right. These are double angle identities, yes. Yes. Scroll up a little bit to there still. Yes. They're not, no, you can prove a theory,
So technically.
but
They're not
they're not necessarily
necessarily use them.
true.
They're not. So math is a lie.
So we don't have to use them. That's what I'm
Most of math.
because they're not necessarily
Most
true.
of math is also
Who
imaginary.
invented calculus?
Some idiot who was like,
Oh, sure. I
I
know
feel
that.
like we'll be fine without math.
If I could go back in time, I'd
Like what the world really.
We wouldn't have computers or iPhones without math, so don't
I'd live
say
with that.
we would
I'd
be
be a
fine
prairie
without math.
farmer, you go to the prairie.
You
So what are I think it's amazing.
But they still
I would look into like.
Okay.
Um.
You know, that's I hope that that's enough to get us by for today. So,
Hold on. You still haven't explained.
what means?
I don't understand.
Huh?
Did you not take trigonometry?
This might hurt.
How are you in calculus without taking trig?
I don't know.
Wait, you're in for a world.
Yeah,
Trig is a prerequisite of calculus.
I don't know how I got in.
Yeah, that's
Good luck, Nick.
Fear shot. Isn't it a prereq?
yeah, it is.
I don't know how I got in.
Tony, well, Tony's smart. He'll be fine.
I'm pretty sure I signed up for trig and not this.
All right. So let's do this problem. All right. So where's the complicated part of this problem? The denominator. Okay. So let's leave the numerator as 1 minus cosine of theta. Let's change the denominator into 2 times. What is sine squared of theta equal to? 1 minus cosine squared of theta. Very good. Ding, ding, ding. Right answer. Okay. How do we get that? No. From the Pythagorean identity right here. Pythagorean identity. Sine squared of theta equals 1 minus cosine squared of theta. Right? So sine squared of theta equals 1 minus cosine squared of theta. No. Sine squared plus cosine squared equals 1. So if we subtract cosine squared from each side, sine squared is positive. So, you know, that was a very excellent question, though. You were thinking. All right. Now. All right. Here we go. So we have 1 minus cosine of theta in the numerator. Does the denominator factor? Yes. 1 minus cosine squared is difference of squares. 1 and 1 plus and minus cosine of theta, cosine of theta. Oh, look. Cancel.
Oh, I remember this.
1 is on the top over 2 times 1 plus cosine of theta. Unit circle. What's a cosine of 0? 1. So we have 1 over 2 times 1 plus 1, which is 1 over 2 times 2, which is 1/4. Oh, I found an answer. The limit of that is 1/4. Trey, if we have a squared minus 9 and we're told to factor that, we factor it into a and a plus and minus 3 and 3.
How did you get that on the first part, Mr. Beerbach?
Oh, you mean here to here?
Oh, I get that.
That's a trig identity right here.
I can't figure it out 'cause he's got all those circles.
You have to move the cosine to the other side. Let's do one more of those, man. Where are we at? Oh, right there.
Oh, now it's a ring?
Now we have to use
We've been in radians. The last one was in radians.
Wait, so this is just the same thing instead of theta and
Yeah.
Okay, I'm just gonna pull up this thing and just
Okay. So if we put pi over 2 in here, we have 3 times, the cosine of pi over 2 is 0. 3 times 0 squared. The sine of pi over 2 is 1, so it's 2 minus 2 times 1. So we get 0 over 0. What kind of form were we in? That one thing. Indeterminate form. 0 over 0 is indeterminate form. Okay. So, since we're in indeterminate form, I got to see what I can do. Okay. Now, which one should I manipulate? My numerator or my denominator? I reckon the numerator too. Cosine squared. Because you can't manipulate this much besides taking a 2 out. So cosine squared is 1 minus sine squared. And on the bottom, I'll take out a 2 to get 1 minus sine of x. Oh, look. I'm pretty darn close, aren't I? I can use a Pythagorean identity, can't I? Well, I already used my Pythagorean identity. I can use differences of squares factoring. Why are you saying cosine? We just changed from cosine to get to sine, so we can use differences of squares factoring. So 1 plus sine of x, 1 minus sine of x. Denominator, 2, 1 minus sine of x. Catherine, what is your question? No, 1 minus sine squared of x is cosine. We had cosine here. We changed it into here so we could cancel here. All right. How's it going? We just did a problem which was a warm-up problem for this, so you should be able to do this one. All right. Yeah. Yeah. Okay. So it's 3 times 1 plus the sine of pi over 2 over 2. What's the sine of pi over 2? 1. So it's 3 times 1 plus 1 over 2. So we get 6 over 2, which is 3.
boom.
That's the limit of that function.
This is so easy, bro. I'll tell you what.
What's your
Don't say that to Mr.
Like,
All right. Hold up. Who's being a brat? Me?
Yeah, you.
Wow.
You want to fight?
Whoa. Whoa.
He's mad.
I got to think about that one.
He's like, is this worth losing my job over?
Is Kate worth losing my job over? Probably not.
Probably. All right, let's take it down. Let's down. All right, yes.
Okay, here we go.
Pythagoras theorem.
You? Yeah, I agree.
As it implies.
All right, before lunch we have.
Whoa, what? Before lunch?
Yeah, we're gonna do more after lunch.
What?
Fishbach, please.
Whoa.
Calm
What's
down.
going on?
I don't think I do that much.
Yeah, no, this class.
Sorry, anyone else like
I'm still on.